What if the sharp black ring we call a black hole's edge is not really the edge at all, but just the place where light gives up while a physical membrane underneath keeps straining and breathing? In the energy filament theory, what we call the event horizon is not a perfect geometric line in spacetime, but a real, ultra-tensed tension membrane in the energy sea. A stretched skin with structure, stress, and pores. Textbooks usually define the horizon as a mathematical radius where escape velocity equals light speed. Then quietly treat it like an invisible fence. Cross this radius and nothing, not even light, can come back. In this picture, that same location is still the point of no return for outgoing light. But the focus shifts from geometry to material. There is an actual outer critical layer of the energy sea there, pulled so hard that it behaves like a physical film. To get a feeling for it, imagine a soap bubble blown to its absolute limit. From across the room you only see a clean, smooth circle, maybe with a hint of color. Move closer and you notice the film is so thin it gleams. And it is never quite still, it shocks, thickens and thins. And sometimes micro holes appear and heal faster than your eyes can follow. The horizon in this view is like that, only more extreme. It is the ring where any light that tries to leave is dragged into a tension slope so steep that, for a distant observer, its path stretches into infinity and its outward progress slows towards zero. At the same time, that ring is the outer face of a physical tension shell, and is constantly under attack from inner pulses and outer infalls. So why do we see such a crisp, stable black ring if the underlying membrane is so busy? Because what your telescope records is not the membrane itself, it is light's performance at that location. As photons climb out from just above this critical layer, they have to fight both the tightness of the energy sea and the extreme time dilation that lives there. Their paths are bent, their climb takes longer and longer in your coordinates, and their frequencies are dragged down. From far away it looks as if the last light is stuck just above a fixed circle, fading and slowing and never quite escaping. That frozen-looking rim is what we call the visual horizon. Underneath the optics, in the same place in space, the outer critical layer, the tension skin, is doing something much more physical. It is bearing the load from below as the piston layer pushes and the stoker sends out pulses of tension. It is venting that load in tiny bursts through the pores we talked about earlier, then resealing. It is adjusting its own local tightness to stay just on the safe side of catastrophic tearing. All of these microscopic moves happen on scales in space and time that are too fine for us to resolve. Their net effect on outgoing light is to keep the no-return radius incredibly sharp and stable. From our distance, that stability hides the underlying activity. The way a calm-looking drumhead can hide the complex dance of fibers inside it. In this picture, it becomes useful to separate two ideas that textbooks mash together. The horizon as we draw it in a diagram, the clean circle where light rays asymptotically stall, is an optical surface defined by how light behaves. The outer critical layer at the same radius is a physical surface defined by how tightly the energy sea is wounded and how it responds to stress. They sit on top of each other, but they are not the same concept. Light sketches the horizon as a shadow. Tension holds up the membrane as a real, strained object. When you stare at the silhouette, you see the shadow and infer a boundary. When you think in terms of the energy sea, you realize that the real skin of the black hole is the membrane that light happens to fail at. The punchline is that the horizon is not wrong. It truly is the last line from which light can still, in principle, race outward. But it is only the visual side of a deeper story. The physical edge is the tension membrane underneath, the outer critical layer where the sea is so tight that one more notch of stress would tear it, and where black holes regulate that stress by breathing, venting through pores and coupling to their inner layers. Once you see the black ring as light's shadow on this membrane rather than as a geometric wall in empty space, the whole object changes character. It stops being a purely mathematical boundary and becomes the living surface of a four-layer tension machine. In the next episode we will lean fully into the light side of the story and ask why every path a photon can take near a black hole tilts into a steeper and steeper tension slope until it has no realistic way back out at all. Tap follow, Share it on New Physics, Clear Universe.